Hello everyone, welcome to GeoGebra High School Edition. As I am sure that you are already aware, GeoGebra is a mathematics app that is used to help one in understanding mathematical concepts and solving problems. You can use all the information in this tutorial to help you with your homework and revise for tests. In this tutorial, I will explain how to plot lines, shapes, and find their areas. In addition, for those who are in grade 7 or 8, I will explain how to plot linear equations and what they are if you haven't learned about them yet. You will encounter them sometime during your high school years, most likely in grade 9. It will be very easy to pick this up if you already have learned your basic algebra. So here I have my app installed and ready to use. As you can see, my grid is not enabled, so the first thing we must do is enable the grid. Right-click on the graph and select Grid. Your grid should now appear. The first thing we'll go over is plotting lines. So click on the small triangle on the line tool and select Line through 2 points. Click on the point 0, 0, which will be our starting point. This point is also called the origin. Now click on the point 4, 4. If you look to this left window pane right here, which is also called the algebra view, you'll see your 2 points A and B as well as the line A. Now go back to the line and right click on it. Select equation y is equal to mx plus b. If you look to the left, you should see that your equation changed to another form. I'll explain a little bit more about this later on. Okay. Now we'll plot another line. Click on the point 2, 4 and then click on the point 6, 10. Now change this line's equation by right clicking on it and change this line's equation to the form y is equal to mx plus b. If you look over to the left, you should see that this line's equation is y is equal to 1.5x plus 1. Okay. Now I'll explain to you what exactly all this equation business is. I'll start by writing out this equation for you that we keep seeing. Y is equal to mx plus b. Okay. So basically the y and the x in this equation are your coordinates, and they're very simple. All you have to do is plug in the coordinates for each coordinate value. My m is just the slope. So basically I'll explain to you what the slope is. The slope is the steepness of the line, and this represents basically how steep the line will be, or its basically obliqueness. And this generally means that basically how large its slant will be. So if you look at this line, you can see that this line has a lower slant than this line. And if you look at the equation for the first line we created, y is equal to x, the slope of this line is 1, since there's nothing really in front of the x, and whenever there's nothing in front of the x, there's always a 1 there. So that's that. And for the second equation that we created, y is equal to 1.5x plus 1, the slope is 1.5, and we can see that this makes sense what I just said right here, because this line slope is greater than this line slope, and this line is steeper than this line. So that's that. The b value right here, what we're seeing right here, is called the y-intercept, and this just means that basically whatever value will be here will be the point in which the line intercepts the y-axis. So for example, in this line, our first line, we have a y-intercept of 0 because it's just plus 0 right here. So basically it's intersecting at 0 right here, the y-axis. But for the second line we created, it's intersecting at the point 0, 1. So since we have plus 1, which is just the y-coordinate of the y-intercept. Okay, and so basically that's that. If you haven't learned about this already, you'll learn this eventually, and you'll be more prepared later on when you learn it. Now let's look at plotting shapes. Let's delete what we have already here by clicking on the move tool. Always make sure to click on the move tool, otherwise you'll end up creating some object of some sort. So click on the move tool and then click on the object you want to delete. So I'll just delete my writing by clicking on it and pressing the delete key on my keyboard. And you can also highlight whatever you want to delete. So just click down and drag whatever you want to delete. So drag and then press the delete key on your keyboard. Now we'll plot a triangle. So the first thing we need to do is click on the polygon tool, click on the triangle underneath it, and select polygon. Our first point will be 1, 1, so click on 1, 1. Then click on the point 3, 3, and then the point 4, 1. Line to see I have a point right here. I'm going to delete that. Okay. So then once you click on the last point, make sure to always click on the original point to complete the triangle. Okay. So if you look to the left, you can see that we've created 3 points, B, C, and D, and we also have the triangle's name as poly 1. So basically what we want to do here is we want to find the area first. So to find the area, there's actually a very neat trick you can do. See this input bar at the bottom right here? This is where you enter commands to compute functions using the program's terminal. So basically you can enter functions for calculating the area, for calculating the perimeter of certain objects, and you can also calculate circumference of circles. So it's a very unique and useful tool. So the command that we'll be entering is right here. We'll be entering this area, and then square brackets, and within the square brackets you'll be writing the name of this polygon. So in this case the name of this polygon is poly 1, as you can see in the left over to the algebra view. And then make sure to enclose them. Make sure to close it with the square brackets. So I'm just going to type this in. So area of poly 1, and then press enter. Now if you looked over to the algebra view, you'll see a number, and then you'll see that number is A, and its value is 3 units squared. So we can verify that this area is correct by using the formula for a triangle's area. Now it is area equals base times height divided by 2. Okay, so I'll just verify this by entering in the base. So the base in this case of this triangle is 4 minus 1, so which is 3, since this x coordinate is 4 and this y coordinate is 1. And since this line is parallel to this x-axis, we can just subtract the x-coordinates. So that's 4 minus 1 is 3, and then the height is basically the same thing, since this distance is perpendicular distance to this line, the base, is parallel to the y-axis. So we can just do 3 minus 1, which is 2. So 3 times 2, which is the height right here, divided by 2. And basically the 2's cancel out, so we don't have to worry about that. So this is equal to 3. Or if you want to do, we could just do 3 times 2, which is 6, divided by 2, which is also equal to 3. Okay, so we've verified that this command that we've entered is functioning properly, since this 3 units squared is equal to the 3 units squared that we calculated. So that's how you calculate the area of a triangle. We'll now work with a more difficult triangle. So just delete what's on the screen and select that polygon tool again, and then we'll click on the point 1, 1, point 1, 3, and then 3, 4, and then back to the original starting point. Okay, now how do you think we'd find the area of this triangle? It'd be kind of tricky because we can't really find this distance from this point to this base, because we don't really know a formula as of now. So there's actually a very neat trick we can do to do this, to find this find the area of this triangle, and I'll show you what it is. So basically all we have to do is well, we want to show the labels of all these segments on this triangle. So to do this, click on the move tool, right click while you're highlighting each segment, so each individual segment, so make sure you're not highlighting the whole triangle. So once this is highlighted, right click on it and click on show label. This segment is called B, and do the same for this, show label, and then this one. So now you can verify which segment is which by looking over here if you want in the algebra view. Okay. So the next step is to click on perpendicular line through a point, and then click on the base of the triangle, and then click on the point B. Okay. Now click on the point tool, which is this one right here. So click on that, and then click right where this line intersects the base. Now what we want to do is click on the small triangle on the line tool, and then select segment between 2 points. Click on the point B, and then click on the point D. Okay. Now we've done all the steps we need to in order to calculate the area. So now we have all the numbers we need. We have the height of the triangle. We've calculated this by finding this the distance from this vertex, the top vertex, to the base. And we know that this distance is perpendicular and is the height of the triangle because we drew this perpendicular line intersecting the bisecting, as you will, the base of the triangle. So the value of the height is 1.11. Okay. Now let's calculate the area of this triangle using the same method that we used earlier. So area of the polygon poly1. So basically the same whatever I told you before, just enter that again. And you'll get an area of 2 units squared. Now let's verify this. So the area formula is base times height divided by 2. So we know the base because we showed the label of this segment right here, which is B. So it is 3.61 times the height, which is 1.11, divided by 2. And this should equal 2. Now let's verify this on the calculator. So 3.61 times 1.11 divided by 2. So it's approximately equal to 2. So we know we're right. Okay. Just delete whatever's on the screen by using the move tool again. Make sure to select the move tool and then click on what you want to delete. Then highlight this collection of objects and then click delete. Okay. Now let's plot a rectangle. Click on the polygon tool again, and then click on the point 1, 2, then the point 3, 4, then 5, 2, and then 3, 0, and then back to the original starting point. Okay. Now look over to the algebra view again. You should see that we have created our 4 points right here. And the name of this polygon, as usual, is poly1. Okay, so now we're going to calculate the area of this by using the same method. Area of poly1. Now press enter, and then you should see your number E, which is 8 units squared. So the area of this rectangle or square is 8 units squared. You can verify this by using the formula for the area of a square or a rectangle, which is just basically this. So this is basically the side length squared. So this side length here we can verify. We know that all the side lengths are the same. As we can see, the value of each segment is the same. So 2.83 squared. And this should give us 8. We can verify this on the calculator. So 2.83 times 2.83 is equal to 8.0089. So approximately 8.01. So it's pretty much very accurate. Okay, now let's delete everything and let's work with a circle. So I'm gonna just delete all these objects. Okay, click on the circle tool, circle around the center point. So click on this small triangle right here, and then click on circle with center through point. Then click on the point 10, 10. So 10, 10. And then you want to drag the circle so that you can click on the point 10, 16. So I'm just going to zoom out. 10, 16 right there. Okay. So now we're going to calculate the area of this circle by using the same command again. So area of, now make sure that you enter the name of this circle since it's different. So if you look over to the left here, you can see that the name of this conic or circle is C. So enter C instead of poly1 for the area between the square brackets. And then you should see that your area is 113.1 units squared. Okay, so we can verify this by using the formula for the area of a circle. So if you don't already know this, I'll just write it down for you. Area is equal to pi r squared. So we can calculate this by entering it on a calculator. The r in this case is just, we can calculate the radius is basically the difference in the x coordinates. So you have 16 minus 10 since this diameter is parallel to the x-axis. So 16 minus 10 is 6. So we have pi times 6 squared. So then we have 36 pi. And then if we enter in our calculator, we'll do pi times 36, which gives us 113.1 approximately. So we've verified that this area command is functioning properly again. Okay, now we're going to do something a little different. We're going to calculate the circumference of this circle. So if you don't know the formula for circumference of a circle, it's basically just, we can just use pi, 2 pi r. Okay, so before we verify this, we'll enter it on the input command. So the input command for circumference is basically the same thing, but except instead of using the word area, we'll be using the word circumference. So you'll be entering this circumference. Make sure to spell it properly. Circumference of C will give you the circumference of the circle. So circumference C, and then you'll see your new number B pop up, which is equal to 37.7 units. Okay, so now we can verify this by doing 2 times pi times the radius, which is 6. So the circumference is equal to 12 pi, because 6 times 2 is 12, so 12 pi. Let's enter it on a calculator right here. So 12 times pi, so 37.7 approximately. So we have the circumference is 37.7, and we verified this because it matches up with the computed value. So 37.7 units. Okay, so we've pretty much gone over the majority of the things you'll be working with in GeoGebra at this level of mathematics. So to sum up everything we've learned so far, I've gone over plotting straight lines and finding their equations, as well as plotting basic shapes and finding their areas. I have also touched up on finding the circumference of a circle using the software, so this would cover the basic concepts of GeoGebra at the early high school level. I hope you've enjoyed watching this guide and have learned something new.